Elasticity is this. So let's look at elasticity. What is elasticity? Elasticity is the ability of a material to regain, it is the ability of a material to regain its original position after being stretched, after being stretched, after being stretched, after being what? Stretched or compressed, after being stretched or compressed. So you can use your own definition. You can also say that elasticity is the ability of a material to regain its original size, position after being deformed or compressed. Do you understand? And another thing again you need to know about elasticity is deformation. Is what? Deformation. We can say that deformation will occur when an elastic material returns to its shape after being stretched. Like there will be deformation if the material is elastic. That is if the material returns to its position. Do you understand now? But if the material does not return, deformation now will not be, deformation now will be plastic if the material does not return to its normal shape. Okay, let me write it now. Deformation will be plastic, in quotes, if the material does not return to its original shape. Are you there? Again, we can say that deformation formation will be elastic if the material if the material return returns to its original shape. If the material returns to its original shape or position after being stretched, after being what? Stretched. Now let's look at terms terms in elasticity. Terms in elasticity. There are terms in elasticity. One is elastic limit. One is what? Now, what is elastic limit? We can say that elastic limit is the when a maximum when a maximum load a body experience, right, and still do what? And still return to its what? Original position after the force or the load has been removed. Or you can say when a maximum load is placed on an elastic wire or elastic material and the body return to its original shape after the load or the force has been removed from that what? Material, elastic material. And there's another definition to that. We can also say that elastic limit is a point is a point on a stress slash strain or load slash extension graph, right? extension graph beyond which Hooke's 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 law is not obeyed. Are you there? You said it's a point on a stress slash strain or load slash extension graph beyond which Hooke's law is not obeyed. Another one we need to know here is yield point is what? Is yield point. What is yield point? Uh, yield point is a point on a wire where the material cannot return again to its what? Shape. Are you there? You can say that yield point is a point on an elastic wire where the material cannot return to its original position. Cannot return to its original position. Are you there? That is a yield point. On the word yield, it has given off like this is the last point. When you place a load on an elastic material and it gets to a point that the material cannot regain its elasticity, it is a what? Yield point. Now again, number 3 is maximum load. Is what? Maximum load. Maximum load, this is when a load is placed on a what? On a wire that it cannot stretch any further increase. You understand now? Maximum load, when a load, or should I say a force is placed on an elastic wire or material that the material cannot cannot stretch cannot stretch cannot stretch any further increase. Are you there? It is known as maximum load. Do you understand? It's known as maximum load. When a load or a force is placed on an elastic wire or material, now the material cannot stretch any further increase. It is known as maximum load. Number 4, we have breaking point. We have what? Breaking point. This is a point whereby a material has reached what? Its maximum what? Limit. It has gone beyond yield point. It has reached what? It is a point whereby the material has reached yield point beyond which it cannot do what? Uh, Breaking point. This is a point where an elastic where a material has reached yield point. Has reached what? Yield point. You understand? Has reached what? It has break away from its original position. They cannot return. Eh? It has reached what? Yield point that it it can it cannot return to its original position. We can also say that it is when a wire breaks away from its original position and have reached what? Yield point, beyond yield point. Then another thing we need to know here is we need to know Hooke's law. We need to know what? I did not say rules, Hooke's law. We need to know what? Hooke's law. What is Hooke's law? This law states that the force applied to what? To a spring is what? Directly proportional to the what? To the extension, provided that the proportionality limit is not what? Exceeded. Do you understand now? The law states that Hooke's law states that the force applied to a spring is directly proportional to its extension, right? Comma, provided that the proportionality limit, the proportionality what? Limit is not exceeded. Is not what? Exceeded. Now it can be written this way: F proportional to what? L. Are you there? F proportional to what? L. And this is F equal to K L. And K is equals to F over what? L. Are you there? So we can now say F1 over L1 equals to F2 over L2. Good. After this, another thing we need to know are what? There are things under elasticity that we need to know. Things like we have learned about elastic limit, yield point, maximum load, breaking point. We need to know about the graph, the graph of elasticity. And here is E, right? E in what? Here Newton, right? So the graph goes this way. Right? So from here is elastic limit. Here is what? Elastic limit. And this place is E. Why here is what? Y. Right? Here is what? M. And here is what? B. Is that correct? So we now write a graph of what? A graph of what is this? A graph of Hooke's law. I will now say where E is equal to elastic limit, Y is equal to yield point. Is that correct? And M is equals to maximum load, and B is equal to breaking point. Eh? Now we need to learn about force constant. After force constant, we learn what's it called? Eh? Eh? Good. We learn about tensile stress. You have to play here. Cool. Okay, let's talk about strength of material. Strength of materials. Strength of material here in elasticity. First, we have tensile slash compressive, not comprehensive, compressive stress. If you don't want to stress yourself, as the name denotes, you just write stress. Do you understand now? So what is stress? Stress is the ratio of force to its cross sectional area. To its cross sectional area. It is measured. It is measured in Newton per meter square. Are you there? And the formula is stress is equal to force over area. Many a times you need to know the dimension of this in case if they ask you. Let me use this period to show you the dimension of stress. This is force, right? And force is kg ms 2 raised to power minus 2, and the area is meter square. Is that correct? So you have kg m raised to power 1 minus 2 s raised to power minus 2. So you now have kg m raised to power minus 1 s raised to power minus 2. So you have m raised to power minus 1 t raised to power minus 2. This is the dimension of stress. And stress has the same dimension with pressure. Do you understand now? Good. The good news now is that you've known the formula of stress, right? And I'll give you the dimension. This is dimension of stress. I think I saw that question in JAM. Last year. They were asked last year set they asked to find the dimension of stress. This is dimension. Now let's talk about strain. Strain. That is number 2. Strain. What is strain? Strain is the ratio of what? Extension to its what? Original length. Is that correct? Stress is the what? Ratio of what? Ratio of extension to its original length. Either you call it stress or you call it tensile slash compressive strain. Tensile slash compressive strain. It is the ratio of extension of a material to its original length. It has no unit. Are you there? Strain has no unit. So strain is equals to extension over length. You can say E over L. That is strain. Strain. Now the third one is Young modulus. Young what? Modulus. Young modulus. This is the ratio of stress to strain. You don't need to speak English here. The ratio of what? Stress to strain. And it has the same unit with what? Stress. Are you there? It has the same unit with what? Stress. It has the same unit as stress. That is to say, it that is it is measured in Newton per what? Meter square. Are you there? Are you there? Now, next thing now is what? Force constant is what? Force constant. Number 4. Force constant. What is force constant? Force constant is the amount of force that causes a unit extension of a material. Force constant is the amount of force that causes a unit extension of a material. Are you there? Now causes a unit extension of a material. Now the formula is F is equals to KE. F is equals to what? KE. That is K is equals to F over what? E. Do you understand now? Yes. So if you are to find the unit now, this is force per meter. Force per what? Meter. That is, it is measured in Newton per meter or Newton raised to minus 1. Are you there? That is for force constant. The next thing we need to look into here in elasticity is energy stored in elastic material or wire. That is what? Energy stored in an elastic wire. And you know that energy is the same as what? Work done. Is the same as what? So what is work done in elasticity? You can say work done is the force that causes what? What is work done in elasticity? When a force does what? When a force causes an extension, causes a what? An extension in a length of a unit wire. That means there's an impact. Understand? A work was done. So when a force causes an extension in a length of a unit wire, for instance, when you bring a spring balance now, so let's say that thing that iron condemned people usually use to measure the weight of the iron, spring balance, right? To bring that in now and place a load on it, it's going to cause what? Extension in the length of that what? Wire. Because a force now, a load has been exerted on it. Do you understand now? So that compressed spring now will do what? Extend. That means work has been done on it. Do you understand now? So we can now say that work done is when a force causes an extension in a length of a unit wire. And it has a formula. That is W is equals to force perpendicular or distance. Force perpendicular or distance. And this distance, you can say that W is equals to force times E. This distance now is an extension. Are you there? Now, recall you say bet F is equals to KE. F is equals to what? You now come here and say W is equals to KE. But before we say W is equals to KE, you need to know that the force here is an average force. What? The force here is what? An average force. You now say, since the force is an average force, that is F over 2. Is that correct? We'll come back and say W is equals to F over 2 times E, and W is equals to KE over 2 times E over 1. So W now is equals to KE square over 2. Or you can say, or W is equals to half KE square. This is the formula for what? Work done in elastic what? Material. Now let's try one example. Dictate a question. Let's try one example. Now look at the example here. Example said the extension in a string when 5 gram weight was hung from it was 0.56 cm. Full stop. If Hooke's law is obeyed, what is the extension caused by a load of 20 gram weight? Now, option A, 1.12 cm. Option B, 2.14 cm. Option C, 2.52 cm. Option D, 2.24 cm. Jam 1981/43. I want you to understand that whenever you hear load in elasticity, it also implies what? Force. Do you understand now? Good. So here now, solution. We have our F1 here is what? 5 Newton. Our E1 is equal to what? 0.56 cm. Our F2 is what? What is F2? 20 Newton. E2 is unknown up here. So F1 is equal to E1 equals to F2 is equal to E2. Is that correct? So what do? Our F1 is what? 5 Newton over E1 is what? 0.56 equal to F2 is 20 over E1 is E2. When you cross multiply, you're going to have 5 times E2 equal to 0.56 times 20. This is E2 is equals to 0.56 times 20 over 5. E2, this will give you 11.2, right? 0.56 times 20. 11.2 divided by 5. So E2 now will give you what? 2.24 centimeter. Final answer. That is to say that the answer is what? D. Do you understand now? So follow my class for more updates on elasticity.